All right, Algebra 2 and Honors Algebra 2. Here is your quiz 5.1 to 5.4 review video. Again, this is for both classes, Honors Algebra 2 and Algebra 2. All right, so and we're calling both classes College Algebra in the second semester. Again, make sure you want to be in College Algebra. We'll be using that word a lot. The pace will be pretty decent, and the content's definitely going to be a little bit more challenging. Bring your A game every day, folks. Folks, no negative exponents. Simplify. First off, you should do 8 times 5 to give you 50. X to the 5th times x to the 3rd, that is when you add exponents. That's how I got x to the 8th. Y to the negative 3rd times y to the 7th, that's how I got y to the 4th. Lastly, z to the 4th times z to the 5th, that is z to the 9th, which I wrote right here. Okay, I'm not going to give you all the answers here. We have time in class to do that, but here are some of the highlights. Folks, you need to clean this up first. Ask yourself, what is more, x's top or bottom? X to the 5th is greater than x to the 3rd, so there are 2 more x's. Exponent wise, that's what I mean when I ask, you know that. What has more x's? I'm looking at the exponent. The top has 2 more y's, y to the 2nd than is up top, and the bottom has more z's. It has 5 more z's. That's why z to the 5th is down below. I cannot simplify 3 over 4, so 3 over 4 stays. And all of that, which has now been simplified, I'm raising to the 3rd power. This means 3 to the 3rd is 27. X to the 2nd to the 3rd power means there's 3 of the x to the 2nd, so I multiply the exponents. That's how I get x to the 6th. Y to the 2nd to the 3rd power is y to the 2nd, y to the 2nd, y to the 2nd. 2 times 3 is 6 again. 4 to the 3rd power is 64. Z to the 5th to the 3rd power means z to the 5th times z to the 5th times z to the 5th. You multiply the exponents. That's z to the 15th. 14 is the ultimate one. You need to simplify first. First, take care of this one right here. 2 to the 3rd is 8. Power to a power, you multiply all those powers. X to the 12th, y to the 6th, z to the 3rd. 3 squared is 9. X to the 4th, 6th, 8th. Now I multiply. 8 times 9 is 72. X to the 12th times x to the 4th is x to the 16th. Just add the exponents. That's how I got y to the 12th and z to the 11th. Last one on this page, number 7. When I have a power, I have 3 of them raised to a power. I multiply the powers. Negative 2 times negative 6, 12. 4 times negative 6, negative 24. Negative 3 times a negative 6 is 18. If you want all the credit, which you do, y to the negative 24th crosses the denominator and is called y to the positive 24th on the bottom there in the denominator. All right. Next page, folks, just some simplifying to begin with. Going to use a little distribution and then honestly simplify. No big deal. Multiply the first parenthesis by 3. The next one by negative 2. That's why negative 2 times a negative 4x is a positive 8x. Here it looks like FOIL, but remember FOIL is first, outer, inner, last, just 4 terms total. This will give you 6. We're using distribution. 2x to the 2nd goes with the x and the negative 2. Then it's negative 3x's turn to go with the x and the negative 2. Then finally it is 7's turn to go with the x and the negative 2. Underline the like terms and simplify. Reduce and simplify, folks. It's good in math and good in life. Now, I'm going to divide all the terms by 5x squared, y squared. All right, why? Because everything is divisible by 5. Every single term has at least x to the 2nd. Every single term has at least y to the 2nd. When I do that, 50 divided by 5 is 10. Take away 2 x's, take away 2 y's, minus 35 divided by 5 is 7. Take away 2 x's, take away both of the y's. That's why this has no y. All right, moving on. Synthetic division, folks. We are testing to see if x plus 3 is a factor, or set x plus 3 equal to 0. If x equals negative 3 is a solution, is a root to this right here, this expression. If I was going to set it equal to 0, that equation. So plug negative 3 in the cubby. Remember, we're really doing 4x to the 3rd divided by 1x. That's why that 4 comes on down. You write 4 for 4x third, negative 8 for negative 8x squared, 5 for 5x, negative 13 for the constant negative 13. Then I multiply, get negative 12 and add. Yep. Negative 8 plus negative 12 is a negative 20. Negative 3 times negative 20 is 60. 5 and 60 give you 65. Lastly, negative 3 times 65 is a negative 198. Add them together. That is your remainder. So no x plus 3 is not a factor. And then, what does 4 mean? I had 4x to the third. I divided by a power of x, so I'm 1 power less, 4x squared, minus 20x, plus 65, minus the remainder, 208, over what I originally divided by x plus 3. Same type of thing here in number 20. The only difference is what goes in the cubby is positive here. X minus 1, set it equal to 0. Testing to see if 1 is a solution. 2 for 2x to the fourth. I skip x to the third, so I have to put a 0 in its place. Because, folks, your answer is going to involve x to the third. You're doing x to the fourth divided by x. You got to have an x to the third represented in there, so I'm going to put a 0. Negative 3 for negative 3x squared. 8 for 8x. Negative 13 for the constant. Again, bring that 2 down. 1 times 2 is 2. Add them up. 0 and 2 give you 2. 1 times 2 is 2. Add them up. Negative 1. 1 times negative 1 is a negative 1. Add them up. 7. 1 times 7 is 7. Add them up. Negative 6 is your remainder. That's how you write your answer. Everything has 1 power less. Starting with x, 2x to the third. Two different ways to do 21 and 22. The remainder theorem tells you that if you do synthetic division, plug negative 3 into that cubby. 2 for 2x to the third. Negative 5 for negative 5x squared. 0 for 0x and 8. I can do synthetic division, and the remainder is my solution for what is p of negative 3. My answer there. You can also plug negative 3 into the original. You can see that, I don't know, synthetic division might be a little bit less work for you. If you're doing it by hand, it could be less work. If not, they're about the same. But make sure you do both p of negative 3 and p of 5 for each of those. Then we get to some really easy questions to end this. State the degree and the leading coefficient of each polynomial. The degree is the highest exponent, x to the third. The degree is 3. The leading coefficient is the number attached to that exponent, highest exponent. Negative 14 is the leading coefficient. You do not have to simplify fully on 25 and 26. You know that 3x and 2x is going to give you the 6x squared, which is going to be the highest power. It's going to be degree 2. Leading coefficient will be 6. Everything else is just going to be an x or the constant. Folks, it crosses the x-axis one time, so it has one real 0. Look at the end behavior. The end behavior is opposite. Opposite direction equals odd degree function. This crosses the x-axis 4 times, 4 real zeros. The end behavior, my arrows go in the same direction, so same direction equals even degree function. And then last page, Honors Algebra 2, and your quiz review might have a few extra questions added there, but Algebra 2, this is it. So describe the end behavior. Your highest power is 3, and that's an odd number, so it's odd degree. That means you're going to go in opposite directions. Positive, and you can start with that. The leading coefficient is positive, so you know it has to end by going up because it's an odd function. The other way, the other end behavior is going down right there. The other arrow is going down, that is. All right, so start with a leading coefficient that is negative, right? That means it ends by going down. I can put that there first. It's even degree, so that means my end behavior is the same direction. That's why that one goes down as well. Same type of question. I changed this. This was a graphing calculator one before. So what you have to do on 33 is note that the leading coefficient is positive, so it's going to end by going up. It is an even degree. It's to the fourth, so it also goes up in that direction. Because it goes up forever in both directions, it definitely does not have an absolute max. It will have an absolute minimum, though. Whatever's down here. Again, we saw something raised to the fourth earlier. Some folks will say there are local mins and max on that. I don't really care. We're not in calculus to find those right now. This one definitely has an absolute min. That is what we care about most, and we'll talk about that in class again. 34, notice how the leading coefficient is negative, so it's going to end by going south. It is an odd degree function. To the third power is odd, so it ends going that way. It's not going to have an absolute max. That's going to go to infinity. It will not have an absolute minimum. That's going to go to negative infinity. But it will have a local min and a local max. All right. ninths. We'll talk more about those later. Folks, that is your quiz review video for 5-1 to 5-4 quiz. This is Yak Math Videos signing out.